Раз, 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 раз. Так, қазір мен естіліп тұрса, қазір біз лекцияны жалғастырамыз бағанағыны. Сосын лекциямыз аз қалды, соны бітіріп, одан кейін сіздердің тапсырмаларыңызға қарап шығамыз. Естіліп тұр ма мені?
Естіліп тұр.
Жақсы.
Requisite programs assist in controlling or preventing the introduction of food safety hazards through the work environment, eliminate, prevent, or reduce to an acceptable level the contamination of the products, including cross-contamination, to control, minimize, and or prevent food safety hazards. In clause 8.2, ISO 22000 requires that effective control measures should be in place to reduce the risk of contamination of the food when establishing PRPs. The organization shall consider from construction, layout, buildings and associated utilities to product information, consumer awareness, and others as appropriate. We'll come back to these in a minute. The organization shall establish, implement, maintain, and update PRPs to facilitate and or prevent and or reduction of contaminants, including food safety hazards in the product processing and work environment. When selecting PRPs, the organisation should ensure that applicable statutory, regulatory, and mutually agreed customer requirements are identified. The organisation should consider the applicable part of ISO 22000 series, that's new in 2018, and applicable standards, codes of practice, and guidelines. Training. All employees that can affect product safety need to be competent to carry out their activities based on training, work experience, or qualification. So the organisation should consider the applicable part of 22002 series. For food manufacturers, these requirements are described in Technical Specification ISO TS 22001, Prerequisite Programs on Food Safety, Part 1, Food Manufacturing. This technical specification does not duplicate requirements given in ISO 22000 and is intended to be used in conjunction with ISO 22000. So, ISO 22002 Part 1 specified detailed requirements to be specifically considered in relation to ISO 22000 Clause 8.2 for food manufacturing. It includes requirements for construction and layout of buildings, including requirements for environment, location of establishments, layout of premises, including internal design, layout, traffic patterns, internal structures, location of equipment, laboratory facilities, temporary mobile premises and vending machines, storage, the requirements for utilities, air, water, and energy, requirements for water supply, boiler chemical, air quality and ventilation, requirements for compressed air and other gases, for lighting. There are requirements for waste disposal, including containers for waste, waste management, and drains and drainage. There are requirements for equipment suitability, cleaning and maintenance. In that, equipment should be of hygienic design. There are requirements for product contact surfaces, requirements for temperature control monitoring equipment, requirements for cleaning plant, utensils and equipment, and requirements for preventive or corrective maintenance. There's a section on management of purchased materials, including requirements for selection and management of suppliers, and incoming material requirements. There's a requirement for measures to prevent cross-contamination. Requirements for systems to be in place to prevent, control, and detect product contamination, including allergen, microbiological, and physical contamination. There are requirements for cleaning and sanitation, for cleaning and sanitizing agents and tools, cleaning and sanitizing programs, CIP, cleaning in place systems, and also for monitoring cleaning and sanitation effectiveness. There are requirements for pest control and prevention, and requirements for personal hygiene and employee facilities, such as personal hygiene facilities and toilets, canteens, workwear and protective clothing, health status, illness reporting, personal cleanliness, personal behavior. There are also other requirements for control of rework, for the storage, identification and traceability of rework, and the use of rework. There's requirement for product recall procedures and warehousing requirements, including those for vehicles, conveyances, and containers. There's requirements for product information and consumer awareness. Product information should be presented to consumers in such a way to enable them to understand its importance and make informed choices. And finally, there's requirements for food defense, biovigilance, and bioterrorism. Management need to assess the hazard to products posed by potential acts of sabotage, vandalism, or terrorism, and put in place proportional protective methods, including access controls. So, when selecting or establishing PRPs, the food safety team will need to consider and utilize appropriate information such as statutory and regulatory requirements, customer requirements, recognized guidelines, codex principles and codes of practice, national, international, or sector standards. The prerequisite programs will need to be appropriate and implemented across the entire production system and be approved by the food safety team. Traceability requirements. A traceability system should be in place to identify incoming material from the suppliers and the first stage of distribution route to the end product. There's also requirements for emergency preparedness and response. Top management shall ensure procedures are in place to respond to potential emergency situations or incidents that can have an impact on food safety. There's also a new requirement in 2018 for handling of emergencies and incidents. So on to hazard control and preliminary steps. To carry out hazard analysis, preliminary documented information shall be collected, maintained, and updated by the food safety team. This shall include, but not limited to, applicable regulations and customer requirements, the organization's products, processes, and equipment, food safety hazards relevant to the food safety management system. So, all raw materials, ingredients, and product contact materials shall be described in documents to the extent needed to conduct the hazard analysis. The characteristics of end products shall be described in documents to the extent needed to conduct the hazard analysis. Intended use. The intended use, the reasonably expected handling of the end product, and any unintended but reasonably expected mishandling and misuse of the end product shall be considered and shall be described in documents to the extent needed to conduct the hazard analysis. Flow diagrams. The food safety team shall prepare flow diagrams. The flow diagrams shall then be confirmed for accuracy on site by the food safety team and retained as documented information. Description of processes and process environment. The food safety team shall describe to the extent needed to conduct the hazard analysis, the layout of the premises, including food handling and non-food handling areas, processing equipment, contact material, processing aids, and flow of materials, existing PRPs, process parameters, control measures, and the strictness to which they are applied, all procedures that can influence food safety, and also external requirements. On to hazard analysis. The food safety shall conduct a hazard analysis based on the preliminary information. The food safety team shall identify and document all food safety hazards that are reasonably expected to occur in relation to the type of product, type of process, and process environment. The food safety team shall identify steps such as receiving, processing, distribution, at which each food safety hazard can be present, can be introduced, can increase, or can persist. Food safety hazards are identified and recorded by the food safety team based on experience, external and internal information, statutory, regulatory, and customer requirements, customer complaints, and previous non-conformances. The food safety team need to consider biological, chemical, and physical hazards. There may also be a need to consider allergens, which is quite common, and sometimes radiological hazards. Biological hazards can be associated with raw materials from which products are made, or may be introduced during the process by people, the environment, or the process itself. Naturally occurring chemical hazards include aflatoxins, mycotoxins, and shellfish toxins. Added chemical hazards are those which are usually unintentionally added to ingredients or food. Foreign materials such as glass, metal, or plastic are typical physical hazards in products through lack of control while the food was being produced. There are many possible hazards. Your food safety team should be aware of those relevant to your products and processes. The first step in identifying hazards which might be associated with your process might be considered a brainstorming session. The hazard team consider all of the hazards that may be reasonably expected to occur at each step from primary production, processing, manufacture, and distribution until the point of consumption. Identify which hazards of such a nature their elimination or reduction to acceptable levels is essential to produce a safe food. In conducting the hazard analysis, wherever possible, the following should be included: the probability of the hazard occurring, the severity of the adverse health effects, the qualitative and/or quantitative evaluation of the presence of the hazards, survival multiplication of microorganisms of concern, production or persistence in foods of toxins, chemicals, or physical agents, conditions leading to the above. So ISO 22000 clause 8.5.2.2.2. The organization shall identify steps at which each food safety hazard can be present, be introduced, increase, or persist. When identifying hazards, the organization shall consider the stages preceding and following in the food chain, all the steps in the flow diagram, the process equipment, utilities, services, process environment, and persons. For each food safety hazard identified, the acceptable level of the hazard in the end product is determined, justified, and recorded, taking into account regulatory and statutory requirements, customer food safety requirements, historic information, scientific literature, professional experience, intended use of the end products, and other relevant information. This hazard list is referred to as a preliminary hazard list and covers all the hazards that could potentially occur in the product. Hazard assessment. Each potential food safety hazard should be risk assessed to determine whether its elimination or reduction to acceptable levels is required to produce a safe product, and also any controls required to achieve the acceptable levels. For each step, grades of impact, the severity of the adverse health effects in relation to the intended use, and the probability, the likelihood of its occurrence in the end product prior to application of control measures, are allotted, and the combined matrix used to judge the significance and priority for elimination and minimization of the hazard. So, the food safety team assessed the likelihood of the hazard occurring. Then the food safety team assessed the severity of the hazard. The food safety team determined all the significant food safety hazards. In this example, the food safety hazards that score a 9 are regarded as significant and form the significant food safety hazard list. 8.5.2.4 Selection and categorization of control measures. So, the hazard team must then consider what control measures, if any, exist, which can be applied for each hazard. More than one control measure may be required to control a specific hazard, and more than one hazard can be controlled by a specific control measure. The hazard team should select an appropriate control measure or combination of control measures that will be capable of preventing or reducing the identified significant food safety hazards to define acceptable levels. So, for significant hazards, decide what control measures are in place for the hazard. When developing your hazard analysis, it's important to keep supporting documents such as regulations, scientific papers, studies, in-plant studies, and historical information about the process for the decisions reached by the team. So, selection and categorization. Using a systematic approach, the food safety team should categorize selected identified control measures to be managed as OPRPs or at CCPs. For each of the control measures selected, there needs to be an assessment of the likelihood of failure of its functioning, the severity of the consequences in case of failure of its functioning. For each of the control measures selected, there needs to be an assessment of the feasibility of establishing measurable critical limits and/or measurable observable action criteria, feasibility of monitoring to detect any failure, and the feasibility of applying timely corrective actions in the case of failure. So, what is the likelihood of failure of its functioning? Consider if, never fails, slight risk, possible failure, likely failure, guaranteed failure. If not effective, modify or look for a different control measure. What is the severity of the consequences in the case of failure? Consider, would a failure mean very severe, life-threatening event to a minor non-mobilizing injury not requiring treatment? Consider, what is the effect on the identified significant food safety hazard? Eliminates it, significant reduction, some reduction, little effect. Consider what is the location in relation to other control measures. At the end of the process, near the end, mid-process, start of the process. Is a control measure specifically established to reduce the hazards to an acceptable level? Is a control measure a single measure or is part of a combination? What is the feasibility of establishing measurable critical limits and/or measurable action criteria? What is the feasibility of monitoring to detect any failure to remain within the critical limit and/or measurable observable action criteria? So, can be monitored to detect any failure 100% of the time, to very little monitoring. What is the feasibility of applying timely corrections in the case of failure? For each, consider if the control measure is likely to be a CCP, OPRP, PRP, or not effective. Non-effective control measures should be modified, or you should look to choose a different control measure. It's good practice to make notes of your findings of the assessment of control measures. So, I prefer to use a traditional codex decision tree to confirm critical control points. There's no requirement for this. An alternative was provided in guidance but withdrawn. As long as your method is logical and the decision-making process is documented, that's fine. So, are control measures in place for the hazard? Does the step eliminate or reduce the hazard to an acceptable level? Could contamination occur at unacceptable levels or increase to unacceptable levels? Will a subsequent step eliminate or reduce the hazard to an acceptable level? So by doing that, I confirm CCPs. But the food safety team also need to validate that control measures and combination of control measures included in the hazard control plan are capable of achieving the intended level of control of the food safety hazards. When validation results fail to confirm the above, then the control measures are re-evaluated and appropriately modified or changed by the food safety team. So confirm your decisions if control measures are to be implemented as CCPs or OPRPs or PRPs. So, the food safety team have now decided if control measures are part of operational prerequisite programs or CCPs in the hazard control plan. Significant hazards that are not CCPs should be controlled by operational prerequisite programs. Other hazards identified in the preliminary hazard list should be controlled by prerequisite programs. So on to hazard control plan. Again, this is new in 2018. The requirement for hazard control plan, HACCP/OPRP plan. The hazard control plan needs to include food safety hazards to be controlled at the CCP or OPRP, critical limits at CCPs or action criteria OPRPs, monitoring procedures, corrections to be made if critical limits or action criteria are not met, responsibilities and authorities, records of monitoring. An action criterion is established to determine whether an OPRP remains in control and distinguishes between what is acceptable and unacceptable. Many control measures are commonly applied in food processing. Not every process is the same, and that is why it's so important to use your own hazard analysis. Some of these may be CCPs or OPRPs. From the withdrawn guidance 2004, you should consider considering the impact of a control measure on the hazard level or frequency of occurrence. The higher the impact there is, the more likely a control measure is a CCP. Considering the severity on consumer health of hazard that the measure is selected to control, the more severe it is, the more likely it is to be a CCP. The more need.
Так, осымен лекцияны аяқтайық. Қазір сіздердің жұмыстарыңызды бір қарап шығайық, үлгергенше. Сосын екінші сабақта қалғандарымыздың жұмыстарын қарап шығамыз. Мені естіліп тұрсыздар ма?
Иә.
Кім бастайды?
Қазір тұрады, қазір мен көріп тұрайын. Систардан бастайық. Систарды көріп тұрайын, не істейді. Так, бұл сендердікі ма?
Да.
А что этот не подписанный? Кто что делал? Чем занимался?
Мы уже в универде добавили.
Ау? Назым,
В универде добавили сол жасаған адамдар ма? Да.
ну, онда жазып қойыңдар келесі жолы.
Хорошо, исправим.
Ага. Так, вот на первый вопрос, по-вашему, кто? Кім жауап береді бірінші сұраққа? Бәріптен осымен айналысыңыздар ғой. Так, тыңдап тұрмын. Міне бірінші сұраққа
Жауап бере берейік па?
енді ешкім жауап бергісі келіп отыр.
Иә.
Екінші сұрақ.
How many standards?
Кене атсалысыңыздар. Магистранттар. 20 адам отырсыздар.
Апай қазақша жауап берерсе бола ма?
Болады, жауап беріңдер қазір.
Оксфорд системасы екі стандарт арқылы жасалады. Ол так, қазір. Аптықша айтып ала ма?
Иә.
Иә, болады. Этот Оксфорд 18001 және Оксфорд 18002. Бірінші сұрақ.
Так, жарайды, Айдана қабылдайын.
Оксфорд стандарты бұл британдық стандарттар институты шығарған еңбек және қауіпсіздік стандарты. Бұл ұйымдардың өнімдері мен.
Так, менде уақыт бітті дейді. 16:20-да кіреміз, жақсы ма? Естіп тұрсыздар ма?
Иә, естіп тұрмыз.
16:20-да қалғандар тез қарап шығамыз барлығын. Сұрақтарға дайындалыңыздар.